actually. Okay, today we're going to be looking at writing the equations. So if we have a picture of the graph, we're just going to go backwards and write the equation. And so if we know what the cross bounce is, odd it crosses, even it bounces, and so forth, and the x-intercepts are the zeros, this should make sense, and it just follows right along with what we did the other day. All right, so number one. So these first two examples kind of typifies what we're doing. So number one, they want you to, or I want you to write an equation for what you see. Okay, an equation. I'll go ahead and underline an equation because there could be more than one answer. All right, so they will give you a graph. And so let's plot it. So -1, -2, -3. So -1, -2, -3, 1 and 2. Okay, put a 0 at -3, at -1, and also 2. And then I'll graph it in a second. Just get caught up. Okay, at -3, start down low and left, but it crosses. It'll bounce right there, and then it'll cross at 2, so something like that. Okay, there's our graph. Okay, so it says write an equation for this. Okay, well, there's a ton of different equations we can write, but as we write these equations, if it crosses, what should the exponent be? Odd. Okay, and if it's odd, although we could put something different, I would just say let's go to the first power. We can go to the 5th power if we want, but let's just go to the first power. And if it bounces, what power should we? Even, so what should we go? Let's go to the 2nd. Let's make it squared. And if it's odd, so to the 1st. Okay. All right, so let's start writing this. So y is equal to, well, wait a second, it opens down and down, so our leading coefficient is negative. Okay, so let's just make a negative number up. So I'll just do -1, although we could put -17 if we wanted to. But let's put negative, because we know it's a leading negative. Okay, now let's start writing the equation. So let's start with this one. So if there's an x-intercept at -3, what's one of our factors? There you go, x plus 3. And what power should we have this to? To the 1st. Why? It's because it crosses. Let's use that as for the odd. And then times x plus 1 squared. Why squared? Because it bounces off.
So could you use any even or any odd?
You could.
So you could have used 3 for x plus 1.
I could use 3 there, and I could use 22 right here if I wanted to. Because it's an equation. It's an equation. And then times x what? -2. X minus 2. And there we go. There's an equation for this. Okay. All right, number 2. Okay, let's write the equation for this next graph. Okay, let's write the equation. So I'm going to move it up. So this one has to be a little bit more accurate. So, okay, 0, 1, 2, 3. So 0, oops, I'm going to put 0 there. 0, 2, and 3. So do that. So 0, 2, and 3. 3 x-intercepts there. Okay, go ahead and draw crossing, crossing, and crossing. Like that. So 0, 2, and 3. Cross, cross, cross. And then I'm going to give you an extra point on this graph. Let's say this is at -1, -4. Okay, so if we're given a point other than the x-intercepts, okay, we can write the equation of this, meaning we'll find this leading Well, I'll call it the a value in front. Okay, so let's write the equation for this. All right, so let's start. Okay, y equals. We don't know the a value, so I'm just going to put a, the leading coefficient. So put a. We'll find it in a second. Okay, so here's a 0 right there. So what do we put for this? X squared, x cubed. Okay, if it crosses, let's just go to the first power. If it bounces, we'll go to the second squared. Okay, so what do I put for this? X squared, but it crosses. So just x to the first. By the way, I know this confuses some. It's at 0, but can't this just be x minus 0 to the first, right? And so one of the roots is 0, right? So that's still just x. Okay. Okay, let's go to this one. And then we have what? X minus 2 times, and it crosses, so let's go to the first, times x minus 3. Okay, so it looks like we got a cross, cross, and a cross. We're good. So we need to find this a value in the front. Well, it goes to this point, so how do you think we're going to find this a value? We're going to plug it in. This is your x, that's your y. Okay, so y is negative 4. So negative 4 is equal to a times, wherever you see an x, let's go ahead and substitute negative 1. So negative 1 times negative 1 minus 2 times negative 1 minus 3. And we're going to solve for a. Let me go ahead and put all this together here. So negative 4 is equal to a times, I'll not skip any steps here, negative 1. Okay, negative 3. Negative 1 minus 2 is times negative 4. And let's go ahead and multiply this together. Well, first of all, what's a negative times a negative times a negative? Negative. And so this is negative what? 12. So negative 4 is equal to negative 12a. I'll just put the negative 12 on this side. So let's solve for a. So what does a equal? 3. 3? Negative 3? Let's divide by negative 12. We want to get rid of that. Let's divide by negative 12. So a is equal to 1/3. Positive 1/3. Big difference between 3, right? Oh, a little bit. Would you like 1/3 of $1 or $3? 1/3 of $3. Okay, so 1/3. So that's our a. So let's write the equation. So it's y equals 1/3 x times x minus 2 times x minus 3. And there is the equation of this right there. Okay? Okay. Any questions so far? Okay. Number 3. Let's write the equation. I'm not sure. I don't remember. I think so, actually. Okay. So number 3. So let me graph this out for you. So negative 1, 1, and 2. So put a x-intercept there. Negative 1, 1, and 2. And the graph looks like this. It'll bounce. Bounces right there. Crosses. And crosses. I missed it. There we go. Okay, and I also give you that this y-intercept is at 3, so 0, 3. So let's write the equation. So same idea. Okay, so y equals, we don't know the a value, but we're going to find it. Okay, let's start writing the equation. So we have x plus 1 to the what power? Second power, right, because it bounces, times x minus 1 times x minus 2. There we go. And notice it all works itself out. This is up and up, so it should be an even degree. It's 2, 3, 4, so it's even. And by the way, if this graph was opening down, never put negative a. It'll always work itself out to be negative if it's supposed to. Don't put negative a there. Just put a, and then it'll work itself out. That's if it opens down or whatever. Okay, so we need to find this a value. Let's plug in this point. All right, so there's your x, there's your y. So 3, which is our y, goes a times, now let's plug in 0 for x. So I'll just write it out. Actually, I'll just say it, but write it. So if x is 0, what's 0 plus 1? And what's 1 squared? So it's just times 1 times what's 0 minus 1? Negative 1 times negative 0, so times negative 2. Okay, so we have 3 equals, if I multiply this side, what do I get? Positive 2. So let's call it 2a. So what is a? 3 over 2. Divide by 2, divide by 2. Oops. So a is equal to 3 halves. Should be positive. It opens up. Okay, so let's write the equation. Y equals 3 over 2 x plus 1 squared x minus 1 x minus 2. And there we go. Okay. Okay. So if we understand cross bounds, we know as far as the x-intercepts, writing the factors should be pretty straightforward. And then maybe do a little algebra to get the a value. But okay, so 4a. Okay, you're gonna sketch and write a cubed equation, so cubic equation, such that, and let me give you the problem, f of negative 2 is equal to f of 3, which is both of those are equal to 0. And f of 0 equals 6. So you're going to sketch and write a cubed equation, oops, such that all this stuff right there. So what's the degree of a cubic equation? 3, third degree. All right, let's see what we have here. So we got to sketch it. Well, let me just cover this up right there. F of 3 equals 0. Where do I plot that? F of 3, 0. F of x, so x is 3, y is 0. And f of negative 2 is also 0. Okay, so let's plot that. So negative 2, that's 0. 3, that's 0. And then this is at 0, comma 6. So that's the y-intercept right up there. There we go. Okay, so it says, okay, sketch. Let's sketch the graph. And it's a cubic graph. Okay, how do we sketch this? Oh, and it's got to go. Can I just do this? Well, why not? Goes through there. F of 2 goes through there, goes through there. Can I just do that? Why not? Because it's supposed to be a cubed equation. Okay, so odd degree. What's supposed to happen with an odd degree? The end behavior. They're opposite. They're opposite. Okay, so I can't just do this. That'd be like a, problem. Even. That'd be like an even. So how do I sketch this cubed equation? What's one way we could sketch it? Could I do any ideas? Down. Start down. Okay, so like this. Do what? Okay, go to the 6. Oh, the balance it. There we go. There's a cubed equation, at least when I was odd, right? There we go. Okay, so that'll work. Okay, so write the equation. Well, let's write it. Y equals A times, well, here's x-intercept of -2, so what do I write? X plus 2 times x minus 3 squared, because it bounced. Is that a cubed equation? It is. So there we go. So how do we find the a value? How do we find the a value? Plug in 0, 6. 0, comma 6. There we go. Good. So 6 is your y. So 6 is equal to a times 0 plus 2. So 2 times, plug in 0. So -3 squared is +9, right? Okay, so you have 6 is equal to 18a. So far, so good? Okay. Okay, divide by 18, and a is equal to what? 1/3? 1/3? Okay. And so let's write the equation. Y is equal to 1/3 x plus 2 x minus 3 squared. And there we go. It's a cubed equation. Matches all that stuff up there. Good. What if it asked, so B, same exact everything. Cubed equation, passes through all that stuff, but graph a different graph and write a different equation. Okay, let's see. Let's sketch this. So -1, -2, and 1, 2, 3. It also goes through 6. So same thing, but we want a different graph or a different equation. Still, it's got to be a cubed equation. Is it possible to graph a different cubed equation that goes through those points?
Yes. Yeah.
How is that going to work? Up, then down, like this, and then,
Bounce off.
okay, yeah, we're going to have to bounce because if we go under, we're not going to hit the 6, right? So I agree, bounce, there we go, and like that. There we go. Okay, so that's -2, that's 3. All right, so let's write this equation. So y equals, hey, wait, it's flipped, isn't it? So should I put -a?
No, you told me not.
Well, I told you not to, so don't. So just put a. It'll work itself out. Okay. So a times. Okay, x what? Plus 2 squared times x minus 3. Perfect. We still use 0, comma 6. So 6 is your y. A times, so 0 for x, so 0 plus 2 squared is 4. Plug in 0 for x there, -3. Perfect. So 6 is equal to, and that's -12. Oops, -12. And it works itself out. Kind of neat how it does that. Kind of fun, isn't it? No reaction out there. Okay. Divide by -12. So a is equal to -1/2. Okay, so y is equal to -1/2. That's my a. X plus 2. X minus 3. And there's a second one. Is there a third way to do this? I don't think so. Okay, last problem here. Okay. So number 5. Okay, sketch. And write a quartic function. What the heck is a quartic function? Degree is 4. Degree is 4. Function whose graph passes through 0, -3, and using the words that you'll see, and is tangent to the x-axis at these two places, -2, 0 and 1, 0. Oops. There we go. Let's get caught up there. So sketch and write a quartic 4th degree function whose graph passes through the point 0, -3, it's the y-intercept, and is tangent to the x-axis at these 2 points. What does tangent mean? What is, if it's tangent to the x? Have you guys ever heard, well, I'm sure you have, whether you remember it, in geometry, a tangent to a circle? What is a tangent line?
A straight line.
Say that again? Touches the outside of the circle. Okay, so if we had a circle, perfect circle like that, a tangent on the outside? Okay, you can go through.
Just tell us.
Easy. Okay, a tangent just touches at one spot. That's a tangent. Do you guys know what a secant to a circle is?
Straight line.
Secant. A secant touches twice. Okay, it goes through. But a tangent just touches once. Chord. Like that. That's a chord. Oops. Yeah. Oh. That's nothing. That's nothing. It's just a line that enters and doesn't go all the way through. No. Yeah, there's nothing for that. Well, there's a radius, I guess.
It'd be like
but,
a radius that.
But it doesn't. Oh, yeah. There's nothing for that. Okay, so let's graph this. So 0, -1, 2, 3, -2, 0, and 1, 0. All right. So we want to graph a quartic function that passes through those points, or passes through 0, -3, and it's tangent to the x-axis. So the x-axis is like a tangent line, touches in one spot. So how is this graph going to look? And it's a 4th degree, even.
It's going to be a negative even. It's gonna go.
Okay, negative even. So like this?
Yes.
Okay, and then it does what?
Bounce.
Oh, good. Bounces. Look, it's tangent right there. And then it goes like this and bounces. Perfect. There we go.
Yeah.
Okay, so there's our graph. So let's write the equation. Y equals, we need to find the A value, because this is at 0, -3. That's at -2, and that's at 1. Okay, so, hey, it's opening down, so should I put negative A? Should I put negative A?
No.
Why not?
Because you told me not to.
Because I told Thomas not to. So put A, it'll work itself out. So A times, let's write the equation. X plus 2 squared times x minus 1 squared. There we go. Plug in your numbers and we'll get the A value.
Equals 0.
So -3 is your Y. A times x is 0. So what do we have? 4 times 1, because negative 1 squared. So divide by 4. Divide by 4. So what is A? Negative 3 over 4. Negative 3 fourths. So it does work itself out. And so put the negative 3 fourths there. We got our equation, and life is good. Negative 3 fourths. X plus 2 squared times x minus 1. That's that equation. That's a quartic. This is squared. Sorry. Quartic. Passes through those points, tangent to the graph, and there we go. All right? So how is all that stuff?
Really good definition.
Pretty straightforward.
Yes.
Hopefully, if you know what cross balance is, and we're good to go. Okay, so the assignment is the next section in your packet.